Hey guys, so this is our second video for our Flip the Classroom lesson on the graphs of the other four trig functions. And in this video we are going to look at the graphs of tan and cotan. Okay, so right here, in looking at the graphs of tan and cotan, we're going to sort of follow the same sort of strategy that we did for secant and cosecant. We're going to think about what rotations are going to give us vertical asymptotes. But we're going to go a couple steps further. We're going to get a couple more ordered pairs for these guys to sort of think through how we're getting these graphs. So right here, with the graph of tan, right, we know that we're defined by the ratio y over x, which tells us that we are going to get vertical asymptotes at rotations that give us x values of 0. And rotations that give us x values of 0 are rotations that land us on the y-axis. So right here we're talking about half increments of pi as being the rotations that will give us vertical asymptotes. And we can go ahead and mark those off in our first quadrant. We know that that's going to happen at pi over 2 and at 3/2 pi. But really, since any rotation that lands us on the y-axis is going to be an increment of 1/2 pi, and it's always going to give us an x value of 0, we can go ahead and mark off half increments of pi on our entire x-axis as places where we're going to get vertical asymptotes. Now, if we rotate onto the x-axis, we're going to have a y value of 0, right? So we'll have 0 in the numerator, and we'll either have an x value of 1 or negative 1, right? So whereas we get vertical asymptotes right here for rotations that land us on the y-axis, half increments of pi, integer increments of pi are always going to give us 0, since if we divide 0 by a positive 1 or a negative 1, we're still going to get 0. So right here we can say that our zeros, where we get x-intercepts, are going to come from rotations that land us on the x-axis, and those are going to be integer increments of pi. So again, we can mark those off in the first quadrant, 0, pi, pi, and 2 pi. But we can mark those off on our entire graph, since negative rotations, positive rotations, and any coterminal angle that lands us on the x-axis is going to be an integer increment of pi. So right here we've got zeros and vertical asymptotes that are going to help us define tan. The next thing that we can do is use one more ordered pair to help us get a graph of tan, and we're going to get that other ordered pair from fourths of pi. The nice thing about fourths of pi is that whether the x values and y values are positive or negative, they're going to be the same number, right? So that means that for tan, defined by x equals, or y equals x, rather, or y divided by x, rather, we're always going to get either a positive 1 or a negative 1, right? So right here, pi over 4, a rotation of pi over 4 gives us square root of 2 over square root of 2 for our y over x, and that's going to be a positive 1. So at a rotation of pi over 4, which is approximately right here, we get a positive 1. In the second quadrant, we have a rotation of 3/4 pi, which is going to give us a square root of 2 over 2 over negative square root of 2 over 2. So at 3/4 pi, we get negative 1. 5/4 pi, we get a negative x and a negative y. So those two negatives are going to cancel, and we are going to get a positive 1 at 5/4 pi. That's a fourth pass pi. And right here at 7/4 pi, we can see that we are going to get a negative 1, because right here we have a positive x and a negative y, right? So 7/4, that's all but 1/4 to 2 pi is going to give us a negative 1. And you can kind of see how tan is going to go through one full cycle. We start out at 0, we've got positive 1, then a vertical asymptote, then negative 1, 0, positive 1 vertical asymptote, then negative 1, 0, and we can sort of assume that that trend continues. What we want to do right now is just take a quick look at a program that's going to show us the graph. So the same program we have for the other trig functions we also have for tan. And we want to remind ourselves that we're comparing the y to the x. So the y is in the numerator and the x is in the denominator. As we start rotating through the first quadrant, we've got small positive x values, we've got small positive y values being divided by larger positive x values, right? And that is going to give us ratios of tan that are less than 1, right, but positive. And as we rotate up to pi over 4, they're now equal, which means that we're going to get 1. So we rotate past pi over 4, now we've got x values heading towards 1, and, y values heading towards 1, and x values heading towards 0, which is going to take our ratio up to positive infinity, right? Our numerator, the y values, are heading towards 1, and our denominator, the x values, are heading towards 0. And this gives us a vertical asymptote at our pi over 2. As we rotate into the second quadrant, now we've got negative x values that are at first small and larger y values, but we're going to get negative values from our ratio here, right? And they're going to be large negative values at first. And right here, that means we're coming from negative infinity with our vertical asymptote at pi. And right here, we get really large negative numbers heading towards 1 for that pi over, or 3/4 pi, right? And now, as we rotate past 3/4 pi, now the x values are larger than the y values, so we're heading towards 0 as x heads towards 1 and y heads towards 0. Now, in the third quadrant, remember, x and y are negative. So right here, that means that rotating through the third quadrant, we're going to get positive values. First, we start out with small y values and larger x values, which means that our ratio is going to be less than 1. And as we pass the quarter pi, that's 5/4 pi, we see larger y values and x values going to 0, which means that we're going up to positive infinity for our vertical asymptote. And rotating now through the fourth quadrant, we're going to get negative numbers. And again, those are larger y values and x values close to 0. So basically, we see negative y values and positive x values giving us numbers coming from negative infinity for our ratios up to 1 where they equal each other at the quarter. And then basically, as we rotate past that, we get numbers going towards 0. And that is a cycle of tan. So basically what we can see from a cycle of tan is we've got our tan function going through zeros up to positive infinity into its vertical asymptote. So it's coming from negative infinity and going to positive infinity. And since we know that we're always cycling through those same x and y values as we continue to rotate around the unit circle, we can basically say that we're following this trend between every two vertical asymptotes. And we're going to basically just see this over and over again between our vertical asymptotes that happen at half increments of pi. So right here for our domain, we can say just like, secant, we're going to get all real numbers, and then except half increments of pi. So we'll be able to say x equals pi over 2 plus k pi, where k is an integer, element of the integers. Right here, our range is going to be from negative infinity to positive infinity, all real numbers, right? Right here, we can see that we are symmetric with respect to the origin. We are reflecting points across the origin here. And so right here, we would say that we are odd. We are definitely unbounded because our function values go down to negative infinity and up to positive infinity. So are we bounded? And we'll just say no. Just like before, we're going to basically just identify the y values at the extrema. So we don't actually have any extrema here for tan, so we don't have to worry about any of that. Our asymptotes are happening at the half increments of pi, where we have those holes in the domain. So right here we can say we've got vertical asymptotes at pi over 2 plus k pi, where k is an element of the integers. So that would be our analysis of tan, the graph of tan that we're seeing here. So why don't you guys go ahead and see if you can come up with a graph of cotan. And then what I would say is follow those same strategies. So figure out what rotations are going to give you vertical asymptotes and what rotations are going to give you zeros. And then go ahead and plot the ordered pairs we're getting at quarter rotations of pi and see if you can come up with what the graph of cotan is going to look like. Why don't you pause the video and All right, so with cotan, we are defined by the ratio x over y, which means that we're going to get vertical asymptotes where y equals 0. That's rotations that land us on the x-axis, which of course are going to be those integer increments of pi. So we can go ahead and mark those off on our graph. And our zeros are going to come from where x equals 0 and y equals either positive 1 or negative 1. And so those are rotations that land us on the y-axis. And those are, of course, the half increments of pi. So we can go ahead and mark off zeros or x-intercepts for half increments of pi. Now, we can basically go around to the quarters of pi and get those ordered pairs. They're going to shake out basically the same way, right? Because we're basically dealing with positive in the first quadrant. That's for pi over 4, positive 1. And then right here, 3/4 pi, it's negative positive, so that's going to be a negative 1. And then 5/4 pi, it's negative, so that's going to be a positive 1 for 3/4 pi, or for 5/4 pi rather. And then right here, 7/4 pi is a positive x and a negative y, so that's going to be a negative 1 for an ordered pair. And again, you can almost see how this is going between these vertical asymptotes. We've got vertical asymptote, positive 1, 0, negative 1. Vertical asymptote, positive 1, 0, negative 1. So you can almost fill in the dots here. And basically what we're going to see from the graph of cotan is very similar to the graph of tan. Right here, we start out with that vertical asymptote, and we've got very, very small y values rather in the denominator, dividing larger x values. So we're coming from positive infinity, right, with really large numbers for our ratio. And then as we hit the quarter, they equal 1. And then as x values go to 0 and y values go to 1, we go to 0. In our second quadrant, we've got x values that are negative. And so that means that we are seeing small negative numbers as our x values are smaller than our y values. And then right here, we get to 1 at the 3/4 pi mark. And then as we rotate past that, now we've got larger negative x values dividing smaller, or being divided by smaller y values. And so as y goes to 0, we get our vertical asymptote, we get our cotan going down to negative infinity for that vertical asymptote at pi. Now right here in the third quadrant, we are negative, so that means that the two negatives cancel out, and we can basically just think that we've got smaller y values dividing larger x values. And then right here, they equal each other at 5/4 pi. And then rotating past 5/4 pi, we see x values going to 0 as y values go to negative 1, and that gives us a 0. And then rotating through the fourth quadrant, now we're seeing x values coming from 0 and y values that are larger coming from negative 1, giving us negative function values less than 1. And then right here, they equal each other, and now the x values are larger than the y values, and the y values are negative, so smaller y values going to 0 from the negative side are dividing x values that are positive, and that means that we're going down to negative infinity for that vertical asymptote. And so right here, basically for cotan, we can see that between these vertical asymptotes, we're just descending to negative infinity. We're coming from positive infinity and going to negative infinity for each of these guys. And again, since this is cyclic, we're just seeing that over and over again. My graph might not be perfect over there, but you guys get the idea. The analysis here, we can do just like we did it before. So right here, domain is going to be all the real numbers. And then, of course, except x values that will land us on, rotations that will land us on the x-axis, and those are integer increments of pi. So right here, all real numbers except for k pi, where k is an integer. The range is from negative infinity to positive infinity, right? Symmetric, and actually if we turn this upside down, we are going to get the same graph, so we're going to say that we're odd here. We are unbounded, so boundedness we'll just say no, and then extrema we'll say that we don't have any extrema, almost made that mistake twice. right here there are no maxes and mins, no peaks and valleys, and we have vertical asymptotes at those integer increments of pi, which are holes in the domain. So that's the graph of cotan. What we're going to do now is stop this video, and we're going to talk about how to graph transformations of these other four trig functions.